Hey there. So for the month of January, I figured I'd do something a little bit different. It's pretty cold, not much nature to see outside. Today, where I am, it's about negative 10 degrees right now, so we're going to do a nice indoor video of this lovely deer skeleton that I found out in the woods when I was 17. I saw this sacrum and pelvis sticking up out from under the leaves. I thought that would be a cool thing to take home. It was already dead. It died in nature. And when I found it, it was pretty much all the flesh was gone, so I didn't have to do any kind of weird scraping or whatever they do to get the flesh off when they do this for museums. So I found this, so then I just kept looking for more bones, and I found almost the entire thing. So we've got all of the vertebrae, the skull, the ribs. The only thing I'm missing is both of the front arms, the bottom jaw. Most of the tail, I have one little tail vertebra right here. And then you can't see it right now, but I'm missing the right foot and one of the left toes and the hooves. So that's pretty good. For my first try, I found this when I was 17 out in the woods, and I decided to glue it together little by little. Gluing one bone at a time took a while, plus also forgetting about it and getting preoccupied with stuff for months at a time. So this is 3 years in the making. I finally finished it, and so I'll showcase a video about it. Just how I put it together. I used 3 different types of glue, so maybe it's not the best. This is my first attempt. When I was looking at models of, how to put this together, so I knew everything was in the right place, I was looking at models and I found that if you do this correctly and you get a complete skeleton, these things can go for like $2,000. So maybe if I get good at this, it's something a little bit of a side hustle. There are some areas you see the ribs are a little bit crooked because a couple of them are in the wrong order. And then you'll see some flaws in it too. My methods, you can see the glue sticking out. It's kind of amateur, but that's okay. This is my first attempt. So when I first found this, my thought was that it's really dirty, has a lot of germs, so I've got to get the germs off by soaking it in bleach. So I'm sure it did the trick of killing the germs, but now looking back, I probably would have found a different way to kill the germs because they look nice and white like we'd expect bones to look, but I don't know, I kind of like the original, keeping it true to the original form. There was a little bit of gray on it, like the way that bones truly look. You can still see some of it on some parts, but I'll go through an in-depth analysis of all the different bones, showing what they have in common with us and a little bit of what makes them unique. But anyways, just for the methodology, it was already all the flesh was gone, so I didn't have to do anything with that. There are a couple bones that are still held together by the original connective tissue, so that's pretty cool. But for most of it, I had to use this glue, so I used Gorilla Glue. So I tried super glue first, but obviously that didn't hold up. It's good because it dries really quickly, so when I use these other types of glue, it'll hold it in place for the amount of time that it needs to dry. But other than that, it cracks off pretty easily. And then I used Gorilla Glue, which is good because it's really strong and it expands to fill in the gaps of all these weird shapes. But the drawback of it is that it holds tight, but it's not very flexible. So if you bend it just a little bit, it'll crack. And then we got this. It's called E6000. This is just a very viscous glue. It marks a milestone in my life because this was the first thing, and as of making this video, I'm pretty sure the only thing that I ever bought where I had to show my ID. So it's just a type of glue. The advantage of this is that it's very viscous. So once again, it'll fit in these weird shapes of the bones. And also it's strong, but it's also flexible. So you could give it a little bit of bending and it won't break. But it's still not as strong as the Gorilla Glue, so I use both of them. So anyways, enough of that. Let me just go into an in-depth analysis of all these different bones. Starting from head to toe, we'll start with the skull. Actually, just a quick overview. This is the skeleton of a deer. Probably a white-tailed deer, not based on any scientific evidence, but just because that's what I see a lot in my area. I don't know much about deer, but yeah, this is an adult female deer. So I'll show you some ways that I can tell. First of all, the skull. She's got a nice round skull. So she's got this nice round skull. If it was a male deer, it would have two little protrusions on the top where the antlers grow out of. The antlers aren't bones, but they do grow like directly out of the skull. They're made of like the same stuff that fingernails are made out of. So that's one way you can tell that it's a female. Also, if you look back here, the pelvis is a little bit wider. Back here you can see the pelvis is a little bit wider and bigger. If it was a male, it would be smaller, but you can see this passage here. She has to birth a whole calf through this. It's a bit of a tight squeeze, but it'll do the job. And then this was one of the things that was originally held together by its original connective tissue, but it broke and I had to glue it. And you can see it's not perfectly glued, but I still try to stay true to the original angle of it. And then this is the two halves of the pelvis, and it's held together by a thin little pelvic bone that you can see right here. And this is something, when people are in the army, they have to march all in unison. And, you know, they often take the same stride. So for the shorter people, they still got to keep up with everyone else who's taller than taking big steps. They really got to reach their legs out. So if you see short people in the army, a pretty common injury they get is right here on this pubic bone. So yeah, that's just a fun fact. Our female deer. You can see the width of the pelvis here. So I've showed you how to tell if it's a female, but this is how we tell the age. This is an adult female deer. There's other ways to tell, like based on her size. You can see. If you ever wonder how tall I am next to a adult female deer, this is about it. It's a little bit taller. But yeah, you could see looking at their teeth. The real way to tell how old they are is by looking at their bottom teeth. But I don't have the bottom teeth, so we'll do our best. So on the top row, there's 12 teeth, 6 on each side, 3 premolars right here, and 3 molars. On the bottom row, they'll have incisors that they use to chew, but on the top, they don't have any incisors. They just grind it against this bone right here to grind their food. So that's another difference. They're herbivores, and so they need to grind their food a lot, not really cut it. So they just have small, like one set of incisors, and then most of their teeth is molars. But anyways, I want to show you right here. This is part of the reason why I kind of wish I didn't bleach it, because we don't have the original color of the teeth. They look mostly white. You can still see some black. The thing is with deer is they don't brush their teeth, and that's fine because they don't eat a diet that's all full of sugar and acidic soda and all kinds of stuff. So if humans didn't brush our teeth, then our teeth would rot out of our heads because of the high sugar diet we have. But deer just eat plants, so they don't brush their teeth, and their teeth are fine. But there's one little aesthetic thing that humans would probably be sad if this happened to us. Since they don't brush their teeth, they do not strengthen their enamel. So each time they chew, a little piece of this white enamel gets chipped off slowly over the years, and it reveals this black stuff underneath called dentin. So since I bleached it, I can't really tell how much dentin there is versus enamel. You can see that some of it is left behind. Some of the enamel did get scraped off. So you can tell she's an adult deer because she has all her teeth. She's at least 2.5 years old, but you don't really see a lot of dentin. If this was an old deer, it would be almost all black, and this would be flat too. So you can tell she's an adult, but she probably did not die of old age. She was probably a young adult when she died. And then these are her teeth from the bottom. They're all molars. You can see her palate. All these little ridges in there. You can see a little bit of what she was eating too, still stuck in her teeth. It's white because it got bleached, but yeah, those are deer teeth. You can see a little bit more of this dentin showing on the other side. You can see a little bit better. Alright, so starting with the skull, one really cool thing that I like about my deer skull that I don't see a lot in other deer skulls that you see in museums and nature centers and stuff is you can see these spiral things that are coming out of her nose. These are called turbinates. They're very thin, delicate bones. When I first got it, it was sticking all the way out. You could see it turning to the side. You could see it sticking all the way out to here, but a lot of them have broken off. They're very delicate like this. When they're in your nose, they're fine. They don't really break because they're surrounded by mucus and they're moist and flexible. But now that they're dry, they're very crumbly. They crack off. And so I think just every time I step and produce vibration, it probably causes a teeny tiny piece to crack off. And so it's a lot of it is broken off. And one day, we might not have any of them left. So it's good that I'm taking this video and memorializing it right now. So everyone will know, when I first got this deer skull, it did in fact have the turbinates, which function to kind of swirl the air around in there so that it could be warmed up and moistened before it goes into the lungs. And this is one thing, the key difference between deer and human is the complexity of their sensory organs will tell you which one has better senses. So you can see these turbinates are very complex. Humans have turbinates too, but they're a lot smaller and they're not, not as big, not as complex. They're little finger-like projections. And so there's a lot of factors that go into what makes someone have a better senses, and the structure of the bones is one of them. Deers have a many times more better sense of smell than humans do. And it's reflected in their bone structure. They have more complex turbinates. Most of it has to do with the nervous system, the mucous membranes that surround it, the complexity of that, the structure of their airways and stuff. But it also has to do with the bone structure. So that's one example. And then also, if you look here, her nasal bone broke off somehow. I have them, actually. Let me go get them. Alright, these are the two nasal bones that would make the bridge of her nose. And I didn't attach them to her because I honestly didn't figure out until right before filming this video what they were. And then it just kind of dawned on me that they're her nasal bones. But it's nice to make them detachable because you can see what's underneath them. So they would kind of attach onto her. This is not perfect, just a rough estimate of what they look like. So those go here, but underneath all that, you can see all this cool, complex stuff going on in there. This is what their nasal passage look like all the way back down to their throat. These little hollow parts, they have hollow sinuses. Humans have those too. They also kind of serve as a chamber to warm and cool the air before it goes into your lungs. There's also some immune functions of them too. Humans have 4 sinuses, but deer have 7. So you can see there's another complexity in their sensory system that makes them have a better sense of smell than us. And you can see it travels all the way back. This is where the nasal, it goes, then through the nose, and then around. So here's the back part of the nose. The air travels through here. This is the palate that they use to chew. This is their nasal passage. It will connect to the nasopharynx, which isn't a bone, so it's not here. The nasopharynx will lead to the to the trachea and go down to their lungs to get oxygen. But the sensory information that gets picked up, you can see, goes all the way back there. The nerves that innervate it, the nasopharynx, where the olfactory receptors are, and all throughout the nose. Right here, it'll go straight directly to the brain. All that information. A lot of our sensory organs are right by our skull. The information goes directly to the brain. You can see all kinds of holes in the brain. In the skull. Little blood vessels and nerves come out. Directly out of the skull. There's a bunch in the eye. You can see that big, huge one is where the optic nerve comes through. And then the smaller one next to it. The smaller ones, a bunch of blood vessels. Here's the eye. And then those 2 big holes. I don't know all the anatomy, but yeah, a bunch of nerves that come directly from the brain. So a cool thing about our skulls is that they're actually made of multiple bones that are fused together. So these are actually joints. So a joint is where any two bones fused together. It doesn't have to move. These are joints that don't move. But yeah, these are called sutures. Deer and humans have all the same sutures. So if you think of what this looks like, this is what also our skull looks like. We have one that connects here. I think this is called the coronal. Connects the back of our skull to the front. This is the frontal. Connects the front of our skull. Both halves. This one, I think, is called the sagittal. I may be wrong on some of these, but it connects the occipital to the parietal. And they have it all around. There's some by the nasal bone and the maxillary bone. And some, this one right here connecting the temple. This is a temple of a deer. You could like put your finger in their temple and go straight through their eye. So yeah, this is the sutures of the skull. And the eye, obviously they have eyes that are on the side of their head as opposed to up front like humans. They're animals that are prey animals. So they need to have a really good peripheral vision to see who's chasing them. So their eyes are on the sides of their head. And then we move on to the ear. The ear is another example of how our sensory organs are structured differently, which tells us which one has a better function. So this right here is called the auditory bulla. I only have the one on the left side, but it's basically a little pocket in their ear that houses the inner ear organ, the inner ear bones and structures, and it kind of holds the vibrations in there to get processed and protects those structures, complex structures that are in there. And this is something that deer have that humans do not have. So as you might guess, deer have much better hearing than us. As opposed to other animals, this one is pretty small. So I've heard that cats have really big ones. They have really good hearing. Deer have good hearing too, just not as good. So this part is actually detachable. It's not glued in, it kind of just holds in place. And every time I remove it, I forget to put it back. So I might regret doing this, but just to show you what it looks like. All those little structures that help process the auditory information. Obviously there's nerves and other mucous membranes that help, but a lot of our hearing has to do with our bones. And once again, you see a hole so that information can go straight to the brain. And this is what the auditory bulla looks like. The air enters into this ear, this hole. And this is supposed to be like a solid bubble. But the bottom part is made of a very thin bone that broke off. So let's see if I could put this back properly. Hang on, I'm going to need to turn this off. That's pretty much all I had to say about the skull. This part here, the cranium, so all hollow is where the brain is. So if you picture what fits in there, probably about that big. It's about how big a deer brain is. That's all they need to have a good life. So anyways, we'll move on to the spine, starting with the neck. I have every single vertebra here. That's all intact. Nothing's missing. And fun fact about spines, all mammals have the exact same amount of vertebrae. So you look how long this neck is compared to my neck. That's because of the different sizes of the vertebrae, not the different numbers. We all have the same. A mouse and a giraffe all have the same amount of vertebrae. If you look at a human cervical vertebrae, that's what it's called. The vertebrae in your neck are called cervical vertebrae. If you look at a human one, they look like just a little stack of pancakes. They're very thin. But as you can see, deer have longer necks. They need to bend down to eat vegetation and eat leaves off of trees or whatever they do. So they're much longer. And if you picture a giraffe vertebra, they still have this exact same amount of vertebrae in their neck as humans do. So picture how big that might be. Maybe like this big, I don't know. That's not based on facts, that's just me guessing. So anyways, look at the neck here. There's three different types of vertebrae in your body. These are called cervical. The ones that are part of your neck. The ones that are attached to your ribs are called thoracic. And the ones that are kind of just by themselves, holding up the rest of your body, are called lumbar. So when I found this, I literally I knew I didn't have the full skeleton. I was looking all over for the other bones. I literally turned over every leaf in the area. And what I found, I picked up every bone that I could find, but here's another thing that I found. Yeah, these two bones. So when I was looking for the bones of this, I knew it wasn't a complete skeleton. And so I searched the entire area. I literally turned over every leaf in the area to look for all the different bones. I picked up all the bones that I could find, and I just so happened to find these in addition to the skeleton. So find these two of, a completely different deer that was nearby. So this is the base of the skull that somehow broke off from it. You can see them next to each other. And then the first vertebra is called C1, or the Atlas. Atlas was a character in Greek mythology who held up the entire world on his shoulders. So this vertebra has to hold up the entire skull on its shoulders. So you can see them next to each other. This is the base of the skull and the first cervical vertebra of a completely different deer, much smaller. It was probably a baby when it died, so that's sad. Hopefully it wasn't one of her babies. But anyways, yeah, you can see. So this is the base of the skull. So the brain would be up here somewhere, and then the brain stem would go through this hole and connect to all the rest of the vertebrae in the body. The spinal cord that extends from the brain stem. The spinal cord contains all the nerves, the whole pathway for all the nerves and the rest of your body outside of your brain, for you to be able to move and feel stuff and all your organs to function. So it's very important, the spinal cord. When people injure their spinal cord, they really can't do anything with like an entire part of their body. If they get one all the way in their neck, everything from the neck down they can't function. One back here, lower down in the back, you can't function from the waist down, stuff like that. So the spinal cord is very important. It travels through this tunnel. Throughout all the vertebrae have a little tunnel in them that protects the spinal cord, this large thick layer of bone, to prevent injury, because that's an important thing that you want to protect. So I'll just go through the vertebrae, starting with the ones in the neck and moving down. So these are the cervical vertebra. I show you the base of the skull where the brainstem comes out. C1, the atlas, and then the one right below that, C2, is the axis. So you could see, the way these connect, there's kind of like a little peg on this lower one that connects to a little socket over here. But this one is different. It doesn't have a peg. It has like a little kind of a ridge. I can't show you because it's already glued together. But that allows it to rotate. The rest of these kind of just move back and forth, bending a little bit, a little 1 inch, each. And, if they bend all at once, then this neck can bend all the way over. And you can move your spine a significant amount just by one little bend, adding up. But anyways, yeah, that's what's special about these first two. It's the atlas and the axis that allows this to rotate. But yeah, the cervical vertebrae, they hold up the head. You can see this has a very strong, long neck, which is surprising because humans' cervical vertebrae are a lot smaller and a lot thinner, but they have to hold up a way bigger head than this, with a way bigger brain. But yeah, the deer prioritized having a strong neck. They fight each other. The males fight each other by headbutting each other. So that's important to have big, thick cervical vertebrae, so you don't break your neck every time you do that. So I guess that's a good thing. You can see a little bit of the canal that the spinal cord travels through. And in between each of these, there's a little hole on the side. Little nerves come out. You can see all these holes. The ones that are in between here. Not these. These are something different. But this is where the nerves come out to innervate the whole rest of the body. But over here, Something unique about the cervical vertebrae that the rest of the vertebrae don't have are these little holes. These are different. The nerves don't come out of them. So this hole goes in this way, and then it comes out right here. This is where the vertebral arteries go. So the heart is all the way down here. Has a bunch of arteries. Connects to the aorta, which goes to the whole body. The aorta breaks off and turns into the carotid arteries, which travel up the neck outside of these bones. But there's also another artery that comes off of that, called the vertebral artery. And it goes through all these little holes, all the way up. So you can see this one has that point of entry, but the point of exit is all the way like inside here. So those go up and feed the brain. And they're very important arteries, as you can tell by the fact that they're not just protected by the skin and stuff. Like the carotid artery is all the way outside here. It could be nicked, but this one is very important. It is protected by bones. So that's the unique thing about the cervical vertebrae. Moving down to the thoracic. One thing you could differentiate them is by they have these little shark fin-like appearances. That's what it reminds me of, a shark fin. And they have little articulations where the ribs connect to. Like I said, all places that connect to bones are joints. Not all of them are movable, but ribs are actually movable joints. If they weren't glued down, I'd be able to show you. I'd be able to bend them back and forth. They're movable so that the lungs can expand and contract when you breathe. And then down here, it would be connected by some cartilage and the sternum, which I don't have the sternum either. One thing you can see, they're kind of crooked. The reason why they're kind of crooked, especially this one, is because they're kind of in the wrong order. I wasn't paying much attention when I was gluing them together, and then I glued all these, and I realized this one probably should have went like up here or something, and then it kind of got out of order, but now they're back in order here. And then another thing, you can see that right here, this doesn't fit together properly. So, well, some things that people ask me is, how do you know if they're in the right place? One thing is that that's the only way that they'll fit together. If they're not in the right place, they're not going to fit together perfectly. Like you see this one, I said it was in the wrong place. You see there's a gap right here. It doesn't really fit. It's kind of crooked. And it looks weird. It's supposed to start thin and then expand out the lower it goes. But yeah, right here also, it's kind of crooked. You can see this isn't in the right place. And then that kind of messed up the order right here. So most of your ribs connect two places. Right here between these two, and then on the little spike end of this vertebra. And then the last one down here, you see there's only one articulation point. And right here, there's only one articulation point. So what I think happened was I was just going in order, and there's a rib right here that's missing. There's only 12 ribs on both sides for this skeleton. There's supposed to be 13. That's another thing that's missing from this. So I'm missing two. Actually, I don't think I'm missing them. I think I know where they are. I'll show you in a second. But there was supposed to be a rib that goes right here. And then this rib right here, you can see there's an articulation point. Just one that doesn't have anything. So there's an error that I made. And then this side looks pretty good. This one is in the wrong spot. But that's okay. And the rest look good, and then I'm missing one down here. Let me show you. So on this side, you can see the ribs are also kind of in the wrong orders, like this one and this one should probably be moved up. This one should probably be moved up, switch places with this. And then all the way down here, there's a rib missing. There's 12 on this side. I think I have it right here. I don't know why I didn't connect it, but it would go in like this. And then you can see there's a little bit of movement that it could allow. So I have the rib on this side, and then on this side, I think the rib that is missing, I think it goes right here, and then the rest of these should be moved one down, and this one would go where there's only one articulation. And I think that the missing rib is right here. It's broken. It doesn't have any of the articulation points, so I wouldn't have a way of putting it on. So if I was to make this more accurate, I'd probably move this all down and then just have a missing rib right here. but it's fine. I didn't notice that while I was making it. So there's a little bit of human error on my part. So it's not perfect, like I said, but if I get really good at this, it might be a good side hustle. And then finally have the lumbar vertebrae. These ones are kind of like, they have a little bit of a shark fin on them, but they also have the side fins too. They're like flippers. So these are the lumbar vertebrae. And they also, you can see they don't have any articulation points where any ribs would go. That's also how you tell the difference. And these three vertebrae, plus the sacrum, are all connected by the original connective tissue. So I didn't glue this together. This is what it looked like in its original form. It's a big chunk of cartilage in between each rib and between the rib and the sacrum. It's pretty cool. You can see on each end of the rib, there's a little piece of thin bone. I had to glue all those together. They were not attached to the vertebrae when I first got it. So yeah, between them is a disc that, you know, allows a little bit of space between them so they're not rubbing against each other. And that's another injury that a lot of people get. They get a slip disc, and it causes a lot of pain. And if you don't get it managed properly, then it can slip up this way. Like I said, there's a tunnel in here that houses your spinal cord. The disc can herniate and slip up this way and sever the spinal cord. You end up being a paraplegic. So it's very herniated disc is something to be taken very seriously. But also, you can see on the ends they don't have the hole for the artery like they do in the cervical, but they do have these holes in between each vertebra where different nerves come out and they innervate all the different parts of the body. So this is the spine. Obviously, I don't have the front legs or the shoulder blades. Probably someone came and ate them or something. But an interesting thing about this, you have these two bones. This is one on the other side. They're very small, roundish, irregularly shaped. And when I first found them, I thought they were probably like a patella or a tarsal or a carpal or something like that because of their irregular shape. And so I was just going to save them until I figured out what they're for. But then one day, I don't remember doing this, but it's glued here. I don't remember putting it there. It's kind of weird. I don't know if I looked it up and then I figured it was the right place to be, and then it just accidentally ended up stuck there. But I don't know. I promise, I've never done drugs or alcohol in my life, which a lot of people probably wouldn't believe based on the fact that I have this in my room. But you don't have to believe me. It's true. I don't remember how these got here. They're just glued here, and to be honest, I didn't glue this one. This one was glued, and then this one I didn't glue it. But if you look at it, I just put it here because the other one's there. If you look at it, it fits perfectly in the area. And so it looks like it fits. It would make sense if I, at one point, decided that was the right place to put it from some source on the internet. I don't know what they would function as. Maybe this is where the shoulder blade would articulate to here. But yeah, I don't know. It's kind of a mysterious thing. Maybe she was telling me that that's where that's supposed to go. So yeah, it's an interesting thing. And then over here we got a sacrum. All I have is one tiny little tail vertebra. This is what makes up the tail. Humans have a tailbone, just one tailbone that's made of 5 vertebrae that are fused together. But deer have, I think it's 5 vertebrae that make up their tail, and they're not fused together, and they move, and they're longer. And I think this is a number that actually does vary by species. So humans have 1, deer have 5, squirrels have a lot. So all the vertebrae, the thoracic, lumbar, and cervical vertebrae, all mammals have the exact same amount, but the tail vertebrae, I don't know the scientific name, but that's one that varies among different species. So yeah, here we got another shot of the pelvis. And then, this is the part I didn't show yet because the camera wouldn't show that. This is the legs. So I have the right leg. The foot of a deer starts right here. So that's an interesting thing about them. They don't stand on their feet or their toes. They stand on their hooves, which are the equivalent of toenails. So if you think of a deer, way a deer stands and compare it to a human, it'd be the equivalent of like the Michael Jackson thing, where he stands on the tip of his toes. I can't do it, but yeah, that's how deer stand. So this is the femur. It's a big long bone. You can see different parts of it. Bones need blood too, so there's holes in the bones that allow blood vessels to travel into them and feed them. One thing you may remember learning in school is that bones are made out of spongy bone on the ends of them. So you can see that here, parts where it's broken down. You can see the spongy bone, little holes. It's not a sponge, it's hard, still hard. All the places where it's broken off, you can see the spongy bone, all that is where your red bone marrow is stored. So red bone marrow is basically like the birthing place of all your red blood cells. Every place where you see spongy bone, that's where your red blood cells are made. So your circulatory system and your skeletal system work together. So the spongy bone is mostly on the ends of bones. And then this middle part will have white bone marrow, which is mostly fat, a fat storage. See more holes where the blood vessels run through. This is a big long bone. That's right here. In humans, this is our femur. That's the equivalent. And on the ends, well, so these are called long bones. The ends are called the epicondyle, epiphysis. And then this is the diaphysis. So the diaphysis is hollow. It has white bone marrow. The epiphysis has spongy bone and has red bone marrow. And on the ends, you can see his little growth plates of all the long bones. You can see them right here. This is the tibia, the femur. It's kind of hard to see in other places. But yeah, and these, when they're born, there's going to be a gap between the diaphysis and the epiphysis. It's filled with cartilage to allow the animal to grow some more. And these growth plates are fused, so she was fully grown. That's one more way you could tell the age of this. So you could tell by the fusing of the growth plates, as well as the thing I showed with the teeth. So yeah, you can see with the Gorilla Glue, it's kind of sticking out. I had to use a ton of it because this is a big joint. The knee joint, right here, between the femur and the tibia, that's usually connected by a whole huge bunch of cartilage running all the way here, all the way on the sides, like 4 different ligaments, just to connect these two bones. So it was pretty difficult to connect these with just glue. But yeah, they need a lot of shock absorption, a lot of cartilage and ligaments. A lot of people get injuries here because even that cartilage isn't enough. There's a lot of weight and stuff that goes on here. So in humans, this would be our shin bone right here, the tibia. So it's right here. We have 2 bones next to each other. There's a smaller one on the side called the fibula, which I couldn't find. I don't know if that's just because it got lost, or maybe deer don't have one. I'm not sure. And then this is the ankle. If we were looking at this part on humans, it would be right here. There's a bunch of little square bones, or round, irregular shaped bones that you can see right here that make up our ankle joint. I don't know the names of all of them. This one is called the calcaneus. So right here would be the equivalent of right here, the heel, the calcaneus. And that's what I thought those 2 bones up by the shoulders were. Maybe one of these irregularly shaped tarsal bones, but it ended up where they are right now. Anyways, it's weird. And this is a metatarsal. see another hole for the blood vessels. And this allows it to have the metatarsal is right here in humans. This would be our metatarsal. We have 5 of them. Deer only have 1. So even though deer have more of the tail vertebrae than us, overall they have less bones than us because they only have 1 metatarsal. Metacarpal only have 2 toes on each foot. So, and then these are the toes. They're still not standing on this. So it's made of 2 joints, just like these are our toes here, and this is the equivalent of what it would be. And there's a hoof on the end that they stand on. So most of deer's feet are not really for standing. It functions more like a leg. This is one of the longest bones in the body is their metatarsal, which is what we stand on. And that allows it to have more of a spring-like action. So when we walk, we have 1 joint in our leg that kind of hinges, but these ones have 2 joints, so there's like 3 segments that they're walking on. You can think of it like a spring. Like if you had a short spring, it's not going to bounce as high, but if you have a spring that's taller with more turns in it, it's going to go higher. And so this one has more bends in it. It's a more bendy spring, allowing them to jump higher, and they propel themselves from their back legs when they run, so that'll give them some more force. Same thing goes for their front legs. They have the same 3 joints, allow them to run the way that they do. This one I'm missing is the front legs, unfortunately, the jaw, a couple tail vertebrae, and a couple ribs. So yeah, this is my deer. So yeah, that's my basic overview of this deer skeleton. Probably one of my prized possessions at this point. My first deer skeleton being put together. Just an overview, some cool things about them, what makes them different from us, and what we have in common. Another thing I found, a project that I was going to make, I found a squirrel skeleton, but now that I'm looking at it, these are the bones that I have. I don't think I have enough of it to put it together. I don't have the whole spine, I don't think either. I only have half a pelvis, so I don't think I could do anything with this. But just some cool things about it. You can see the squirrel skull. It has the same auditory bullae that the deer does. But in relation to the rest of the skull, they're actually a lot bigger than the deer. The deer one is bigger, but, you know, as far as like the percentage of the skull that it takes up, these ones are bigger. So you could guess that squirrels probably have better hearing than deer. You can see it doesn't have the turbinates like the deer one does. That's why the deer one's better. It's more well preserved for now. And another cool thing about them, I have the bottom jaw here of the squirrel. If you look at it, I don't know if it'll show up really well, but if you look at it, it looks more similar to if you have an animal with claws. It has this white part here and the darker part. It comes out. It looks more like a claw than it does a tooth. I bet this isn't a tooth at all. It's more like made out of the same stuff that fingernails are made out of. And I bet it grows back too every time they wear it down. So that's a cool thing. Fun fact about squirrels. Their teeth probably grow back, and they're probably made out of the same stuff that fingernails are. So anyways, that's just another comparison. A little bit of different style video, but I figured I'd show off my lovely deer, my lovely lady here. It's a lot of hard work, and I'm glad that I finally get to show it off to the world. And hopefully next time we'll be in the great outdoors. There'll be more cool stuff to see. So thank you for watching. I'll see you in the next one.